Hey everyone, and welcome. Have you ever stopped to wonder how you're able to watch this right now? Or how an email can zip across the planet in like a second? Well, it's all thanks to the incredible hidden world of computer networks. So today, let's pull back the curtain and really see what the fundamental building blocks of our connected world are all about. You know, networks are so deeply woven into our lives, we barely even notice they're there. They've completely reshaped education, right? An instructor in one country can connect seamlessly with learners pretty much anywhere else on the globe.
And they've totally transformed how we talk to each other. We've gone from old-school, voice-only landlines to apps like WhatsApp, where we can share texts, photos, videos, you name it, all in an instant.
And it doesn't stop there. Whether you're logging in to get company files from your home office or jumping into a massive online gaming session with people from all over, networks are the engine that makes both our work and our play possible.
So the bottom line is pretty simple. These powerful, totally invisible structures are holding up almost every single part of our modern lives. Understanding them is really the key to understanding the world we live in today, and that is exactly what we are going to do. So here's our game plan. We'll start with why this all matters. Then we'll get to the most important definition, and then break down the two main building blocks. After that, we'll look at different types of devices, and finally, you'll get a shot to test what you've learned. Sound good? Let's go.
First up, Section 1. Networks are everywhere. We're kicking things off here because once you really get just how much they're all around us, you start to see why knowing the details is so important.
You know, beyond just connecting us, networks are fundamentally about being efficient. Just picture an office with, say, 4 computers. Instead of buying 4 separate printers, you just hook one up to the network and bam, everyone can share it. That's a super simple example of resource sharing, but it's a core benefit that saves a ton of money on hardware.
Okay, on to Section 2. We're about to look at the single most important sentence that defines what a computer network even is. Seriously, everything else we talk about today is going to branch off from this one core idea.
And here it is. A computer network is a set of nodes connected by communication links. That's it. It's really that simple. The two key words you absolutely have to lock in your brain are nodes and links. So let's break those down.
Which brings us right to Section 3, our first building block, nodes. The easiest way to think about these is that they're all the individual things that make up the network.
So, what is a node? It's just any device that has the ability to send data, receive data, or do both. If a device can get in on the data conversation, well, we call it a node. And as you can see, nodes are literally everywhere. Your computer is a node, your smartphone, definitely a node. That office printer we were just talking about? Yep, it's a node too. And even the devices that manage the network itself, like routers and switches, they're also considered nodes. All right, time for Section 4, our second building block, links. So if nodes are the things, then links are simply the connections between those things. The job of a link is incredibly simple. It's a pathway. Its whole purpose is to carry data from one node to another. It doesn't matter if that data is an email, a video stream, or a quick command. The link is the road it travels on. Now, these links basically come in 2 main flavors. You've got wired links, which are physical things you can actually see and touch, like an Ethernet cable. And then you have wireless links, which use an invisible medium, like the air all around us, to carry information using waves. Think about your Wi-Fi signal.
Let's jump into Section 5. Now that we know about nodes and links, we can start to put the nodes into different categories. We can basically split them into 2 main groups, based on the job they do: endpoints and intermediaries.
So here's the key difference. End devices are either the starting line or the finish line for data. Think about your computer when you send an email, or a server that's hosting a website. Intermediary devices, on the other hand, are like the traffic cops in between. Things like routers and switches. They don't create the data or use it. Their only job is to smartly forward it along the best path so it gets to where it needs to go.
And that brings us to Section 6, your turn. It's time for a quick challenge to see if you can put what we've just talked about into practice. Let's see if you can spot the different parts in a real network diagram.
Okay, take a look at this diagram. You can see a whole bunch of different devices all connected together. Based on what we just went over, can you tell which ones are the end devices and which ones are the intermediary devices? Go ahead and pause here if you want a second to figure it out.
All right, ready? How did you do? The end devices are all the ones creating or using the information: the computers, the server, the printer, the tablet, and smartphone. And the intermediary devices are those traffic directors in the middle: the wireless router, the switch, the main router, and the cell tower. If you got that right, you've totally grasped a fundamental concept of networking. Nice work.
So let's lock in the 4 key takeaways from all this. First, the core definition. A network is just nodes connected by links. Simple. Second, nodes are any devices that can send or receive data. Third, links are the connections, either wired or wireless, that carry all that data. And finally, device roles. Every node is either an end device, where data starts or stops, or an intermediary device that just directs the traffic. That's it. That's the basic anatomy of any network.
So we've successfully identified the fundamental parts of a computer network. We know the what. But that leaves us with a really fascinating question. In a global network with literally billions of nodes, how does a single piece of data actually know where to go? How does it possibly find its way from your screen to a server halfway across the world? Well, that's a puzzle we'll explore next time. Thanks so much for joining me.